welcome to online lecture series for software engineering KCS 601. Myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. In this lecture, we will be discussing about the constructive cost models, that stands for COCOMO model, and various other resource allocation models. So, coming to the COCOMO model, this model stands for constructive cost model. This model is being used to calculate the software cost estimation. Since this was first established in 1981 by B.W. Boehm in the software engineering book. The first model is known as COCOMO 81. And then its later versions that was given by again COCOMO 2. So, it is being most widely used for software estimation model. This model, it predicts the efforts, it predicts the schedule of a software product in the terms of size, cost and time. Here in the figure we can see that we are giving the three parameters. One is our cost, another is our time, another is our size, and we are coming the efforts and schedule of my software as a output. So, this model, it is defined in three different models, that is, first one is the basic model, the second one is the intermediate model, and third one is the detailed model. We will be discussing one by one all these terms. So, if we draw the effort versus program size, it comes to this curve. This is my estimated effort, and on the x axis I have taken the size. So, as the size increases, the effort also increases. For the smaller programs, I have to do the little effort. This, according to this graph plot, I can say this output. So, all the three models of my COCOMO, they have been plotted. Organic, it is coming like this curve, this red, it denotes the semi-detached curve, and green one, it plots the embedded curve plotted between efforts and program size. So, if we plot the development time versus program size, this is my nominal development time taken on the y axis, this is the size of program being taken on the x axis. With respect to increase in size, the development time also increases, and after some time it will become constant. So, for the three terms, for the organic, it is being shown by the blue line, the green one shows for the semi-detached model, and the red one it plots for the embedded model. Then, coming to these three modes, they are being termed as development models of my COCOMO. So, they are the major important factor that are contributing towards the project duration and cost. Here I am going to determine what will be the project duration and how the project cost will come out. Means the estimation of the project duration in terms of time, and the software cost is estimated as the output of this COCOMO. So, the first model, that is the organic mode. Organic mode, here the project is developed in a familiar and stable environment, and the product is similar to the previous developed projects, nothing is new. Here my product is relatively small and it requires very little innovation. So, this is organic mode is basically used when my program size is small and it is very familiar to my earlier developed product. Then the second mode, that is my semi-detached mode. Here the program characteristics, they are intermediate between the organic and embedded. Generally this model has been taken because when I do not have very small program and when I do not have very big program. So, by default the semi detached mode comes into the picture. Then the third mode, that is my embedded mode. Embedded mode, here the program is characterized by tight inflexible constraints. The deadlines, they are very sharp, they are very tight, the program is not flexible to the constraints. Then interface requirements, they are also very tight. So, the embedded mode project, it will require a great deal of innovation at runtime. Everything is not defined statically, some things that need to be taken care in the form of innovation in this embedded mode. So, coming to the basic COCOMO model. This model, it computes the software development effort and cost as a function of program size being expressed in the estimated lines of code. So, here the table is being given for the 3 types of mode, the various coefficients, they are being already defined by B. Boehm. So, for organic mode, the values of AB, BB, CB and DB, they are being taken as 2.4, 1.05, 2.5 and 0.38. And then for the semi detached mode, when my program is intermediate, it is not too small, it is not too lengthy, then the value of coefficients, they are 3.0, 1.12, 2.5 and 0.35. Then for the embedded, when my program size is too large, the values are 3.6, 1.2, 2.5 and 0.32. These parameters, they are already calculated. I have to calculate the E, the effort. This effort is calculated as the product of AB into KLOC, that is the lines of code, power the second coefficient, that is BB. This is my effort, it is calculated in person months. This effort will be calculated in person month. Then the second thing that I will be calculating, that is the development time, that is denoted as D. So, this D, it is calculated as CB into whatever effort I have calculated power dB. This suffix B presents for basic model. So, D is my development time and it will be calculated in month. The third thing that I am going to calculate is my number of persons that are required to complete the project, that is productivity, P. P is calculated as E upon D. So, in this way I am going to calculate my effort, my development time and how much productivity of my software product in the form of total number of persons is calculated. The basic advantages of using this basic COCOMO model, it is very good for quick, early and rough estimates of my software product. So, if I want to calculate the effort, cost and productivity very quickly, I want to take a rough figure, then this model is very good. The limitations are the accuracy is limited and it does not consider other hardware constraints or the person quality how much experience he have, which tool he will be using, which language he will be using, they are not being considered in this basic model. That is the shortcoming of this model. Then let us do one numerical based on this basic model. Consider a software project using semi-detached mode, it is given already, with 30,000 lines of code, means 30 KLOC will be using. I have to calculate the effort, development time and suppose productivity also, the third parameter I am adding for this semi-detached mode. I know the formula for calculating the effort. This formula is AB KLOC power BB, second coefficient. So, here my value for semi-detached mode, I know from the previous table, this is being taken as this one 3, 1.12, 2.5 and 0.35. These middle row I will be using. So, the value of AB is 3, BB is 1.12. So, here I will be writing as 3, how many KLOC? They will be 30 KLOC to the power 1.12. So, here the effort is calculated as 135 person month. Then the second parameter that I have to calculate the development time. That is represented as DD, it is the measure of CB, effort that is already calculated power DB. So, here the CB is 2.5, effort I have calculated as 135 in the A part to the power 0.35, it comes out to be nearly 14 months. Then the third parameter, productivity, suppose I have to calculate that productivity, it will come E upon D, that is 135 upon 14, nearly 10, 9 point something it will come. So, here I am writing is at 10. Then the second question, a product size of 200 KLOC is to be developed. The software development team, it has average experience on the similar type of the project, means I will be taking the semi-detached mode. So, the project schedule is also not very tight, and based on these assumptions, schedule is not tight, KLOC is given, I will be taking the semi-detached mode into my consideration. Calculate the effort, development time, average staff size and productivity of the project. So, as per semi-detached mode, the value of E, it will be calculated as AB KLOC power BB. Here the value of A is 3, KLOC is given to us 200 power 1.12. So, it comes out to be 1133.12 person month. This much effort is calculated as the first part. Then the second part is calculate the development time. We know that the development time is given as CB, the effort that I have calculated power DB. The value of CB is 2.5. Effort I have calculated 1133.12 power 0.35. So, it comes out to be 29.3 person months. This the second. So, the second parameter is also calculated. The third one I have to calculate the average staff size. This staff size is now determined as E upon D persons. So, 1133.12 divided by 29.3, that is 38.67 persons, means 39 persons I will be taking. Then calculate the productivity. productivity is termed as KLOC upon E. This KLOC is 200 in this program and effort I have calculated 1133.12 in my first part. So, that comes out to be 0.1765 KLOC per person month, that is the fourth point calculation. So, here I have calculated the four things. The first one effort, the second one is my development time, the third one average staff size, that was E upon D, and the fourth one, that is the productivity of the project, that is calculated as KLOC divided by E. So, that comes out to be 0.1765 KLOC per person month in this question. So, these are the next is these are my cost driver attributes. I am involving now the other parameters into my project. So, these parameters are the product attributes, that is known as the required reliability. The product attributes, they are evaluated in terms of reliability, in terms of database size, in terms of product complexity. Then the second parameter, computer attributes, they are taken care by considering execution time constraint, storage constraints, virtual machine volatility, computing the turnaround time. Then the third thing, we are involving the personal attributes, means how much capable is my programmer, how much experience he is already having. Then the programmer capability, virtual machine experience, programming language experience, and fourth one is the project attributes, means the kind of programming language that is being used in this, the kind of tools that I am using, and the required development schedule. So, these parameters now they will be taken care into the estimation of the cost, that is into COCOMO model, and then I will be re-evaluating my effort, my development time and other parameters. Next is my second type of intermediate COCOMO model. So, it computes the software development effort as a function of program size and a set of cost drivers. These cost drivers that I have just mentioned in the previous slide, means here I am taking the assessment of product, hardware, personal and project attributes. So, giving a rating of 15 attributes that I have just listed from very low to extra high. So, we have to find the effort multiplier and a product of all the effort multipliers that gives us the effort adjustment factor. These are the cost attributes, product attributes, three kinds: reliability, database size and complexity. They are either very low, they are nominal, they are high, very high or extra high. So, accordingly as per this scale their values are calculated and that is given to us. So, for all the 4 parameters, means all the 15 parameters coming to these 4 kind of attributes, their values from very low till extra high they are being already calculated. And next is how I include them in my effort adjustment factor and how I calculate the effort using these cost driver attributes. See that. So, here I am having this table for the intermediate one. My effort is now AI. So, this is my I because it is intermediate model, KLOC की power BI. Earlier the effort was only this EB, KLOC, BB. Now it will be product of EAF also. So, EAF I have to calculate using that cost driver calculation. So, the merits of using this intermediate COCOMO model is it can be applied to entire software for easy and rough cost estimation, and it is applied for calculating the software product component level, and the limitation is many components they are difficult to estimate. Next is the advanced model. It incorporates all the characteristics of intermediate COCOMO model with the assessment of the cost drivers impact on each step of software engineering process. There are 6 phases for this detailed COCOMO model. These phases are planning the requirements, system design, detailed design, module code and test, integration and test, and then cost constructive model. Here my effort is calculated as a function of program size and set of these cost drivers, they are being given to us for every phase. So, these cost driver calculating drivers, they need to be incorporating the effort, development time as a function of every program. The next is COCOMO 2. COCOMO 2, it incorporates the range of submodels that produces the increasingly detailed software estimates. There are submodels in COCOMO 2 also. So, these submodels, they are application composition model, that is, it is being used when the software is composed from existing part. Then the early design model, this is being used when the requirements are available, but the design is not yet started. Then the third kind of submodel, it is my reuse model. As the name suggests, this model, it is used to compute the effort of integrating the reusable components. Firstly, I will identify them, then I need to compute the effort of integrating those reusing components. Then the fourth kind of model is my post architecture model. This model, once the system architecture is being designed and other information about the system is available, is used. There are various stages of this COCOMO 2. The stages are, first is the stage 1, then stage 2, then stage 3. Stage 1 says it supports the estimation of prototyping. This stage 1, it is used for a prototyping stage of the application generator and doing the system integration. Then comes the stage 2. This stage 2, it is being used to doing estimation in early design stage, and then it is used in application generator. Then stage 3, it supports the project estimation in post architectural stage. After this completion of detailed architecture, I am coming to the stage 3. The next is Putnam resource allocation model. It was being proposed by Lawrence Putnam, that is why the name is given like this. So, this model, it plots the person and time, and here I am calculating the finding overall curve for designing and coding. So, the time and effort, they are being described here, they are being estimated here just to finish the software project for a specified size. So, here it is being assumed that it follows the Rayleigh curve to estimate the project effort, schedule and defect rate. So, here we can see we are just finding the project effort schedule and the defect rate, and it is following like Rayleigh curve. Then the software staffing profiles, it follow the Rayleigh distribution, and here I calculate the value of L as Ck, K 1 by 3 and then the TD is 4 by 3, where L is L that I am calculating, it is the product estimate in KLOC. K is the total effort, Ck is the technology constant, and the value of Ck, it ranges from 2 to 11. 2 is for poor development environment, 8 is for good software development environment, and 11 is when I am having excellent environment. So, like this formula, I will be calculating the product estimates that will be coming in KLOC. So, this was all about cost construction models, COCOMO 8.1, COCOMO 2 and Putnam resource allocation model for estimating the software cost. Thank you.